Hello students, welcome back to our channel Food Online. Hope you all are doing good. So in this video, we'll be going to discuss GATE 2020 Food Technology previous year question paper. So let us start now. Index less than 1 is dilatant, pseudoplastic, Bingham plastic or Newtonian. So first we have to see what are these Newtonian fluids and how we can classify them using the power law model. So power law equation we have discussed in our class that it is tau equals to K gamma n, where tau is my shear stress, gamma is shear rate and K is my consistency index and n is the flow behavior index. Now the value of n will decide the type of the fluid. Now if my n is equal to 1, that means this is my Newtonian fluid. If say for example water, milk, oil means viscosity will not change with the shear rate. If n is less than 1, it will be pseudoplastic or we can say shear thinning or shear thinning. Means as we increase the shear rate means it will steer the fast, the viscosity will decrease like ketchup, blood, yogurts, paints. That's why ketchup it will flow more easily when we shake the bottles, right? Next, if n is more than 1, so it will behave as a dilatant or shear thinning fluid. Means the more we will stir, the more it will become viscous. Like cornstarch. Cornstarch and water, there's a term which is known as oblique. This is also important. Okay, this is cornstarch plus water. It is an example of dilatant or shear thickening. And Bingham plastic. So Bingham plastic, basically this is a special case where the fluid it will behave like a solid until yield stress is applied, and after that what will happen, it will flow like a Newtonian fluid. Say for example toothpaste, mayonnaise. So over here our correct option will be option number B, that is pseudoplastic. Since a fluid with flow behavior index less than 1 will be our pseudoplastic fluid. Density of 2.2 micrometer diameter fat particle inside a centrifuge which is running at 6000 rpm and 20 degrees Celsius is 0.2 mm per second. Velocity of 1.5 micrometer diameter fat particle inside the centrifuge tube which is running at 7500 rpm at same temperature will be how much? We have to calculate. Now what are the things it is given? First one, velocity, that is 0.25 mm per second. V2 we have to calculate. Then diameter, that is 2.2 micrometer. D2 1.5 micrometer. N1 that is 6000 rpm. And N2 that is 7,500 rpm. Now we know the formula that in the centrifuge the principle of sedimentary velocity, that is V, is directly proportional to diameter square and its rpm. So we can just write the formula V1 by V2 is equal to D1 by D2 square into N1 by N2 square. We'll just put the value over here and calculate V2. So V2 will be V1 into D2 N2 square by D1 N1 square, which is equal to 0.25 into 1.5 square into 7,500 rpm divided by 2.2 square into 6,000 rpm square. Calculating this, we'll get the value of V2, which will be around 0.18 mm per second. Now we have to round it off to 2 decimal places. So we can write like V2 is equals to approx 0.2 mm per second. So this will be my answer. Initial population of a bacterial strain, it increases from 1 into 10 to the power 4 cells per ml to 1 into 10 to the power 6 cells per ml in 120 minutes. The generation time for this strain is how much we have to calculate. So we know the formula that Nt is equal to N0 into 2 to the power n, or using log we can say that N is equal to log Nt minus log N0 by log 2. We know the value of log 2, that is 0.301. So we'll put that value. So N is equal to log Nt, it is given that 10 to the power 6, 1 into 10 to the power 6 log minus log 1 into 10 to the power 4 by log 2 is 0.301. We'll just calculate it. So 6 log 10 minus 4 log 10 by 0.301, or 6 minus 4, that is 2, log 10 is 1. So 2 by 0.301, which is equals to 6.641. Now this is the value of N we got. Now generation time, it is equals to time by N. So time it has been given, that is 120 minutes, and we have to find the answer in minutes. So no need to convert it, that is 120 by N, that is 6.641. So G is equal to 18.06. So our answer will be 18. Enters a counter current double pipe heat exchanger at 20 degrees Celsius and it leaves at 72 degrees Celsius. Inlet and outlet temperature of the hot water which is used as a heating medium in the exchanger are 81 degrees Celsius and 74 degrees Celsius respectively. The specific heat of the orange juice is 3.74 kJ per kg Kelvin and the overall heat transfer coefficient is 492 watt per meter square Kelvin. The heat transfer surface area, this we have to calculate. So first we'll write what are all the things given. First of all, mass flow rate of the orange juice, that is MC, it is 0.8 kg per second. Inlet temperature of the orange juice, that is TC in 20 degrees Celsius. Outlet temperature 72 degrees Celsius. Outlet temperature of the inlet temperature of the hot water 81 degrees Celsius, and outlet temperature of the water is 74 degrees Celsius. This is inlet, this is outlet. Specific heat of the orange juice 3.74 kilojoule per kg Kelvin. And overall heat transfer coefficient is given as 492 watt per meter square Kelvin. So first we'll calculate the rate of heat transfer for the orange juice, that is Q equals to mCp delta T. M is given as 0.8, Cp is 3.74, and delta T, that is 72 minus 50, it is 52. So it is 150.584 kilojoule per second, or we'll write it as 150.584 joule per second. Now we'll calculate log mean temperature difference, that is delta T Lm. So it is the TCI minus the THO. So it is 20 minus 74, since it's a counter current, minus TCO, that is 72 degree, minus THO, that is 81 degrees Celsius, divided by log 20 minus 74 by 72 minus 81. So we'll calculate this. We'll get minus of 54 minus of minus 9 by log minus 54 by minus 9, or minus 45 by 1.653, which is equal to 27.22 approx. Now we'll just put this all in area formula, that is A is equals to Q by U into A delta T Lm. Q we have calculated 150.584, U it is 492, and delta TLM we calculated it is 27.22, which is equals to 11.2 meter square. Hence our answer is 11.2 meter square. Okay, with this we completed GATE 2020 Food Technology previous year question paper. Hope you find this video helpful. Till then, enjoy learning. Thank you.